All right, so let's review what we have learned so far. First of all, the left is asking you to do what? To simplify. That's what it's asking you to do. But what is the question actually asking you to do? Read the question. What's the question asking you to do? To subtract. Okay? Simplify is just the directions. The question is asking you to subtract. What do you know about a subtraction problem? What do you have to have the same? Can I subtract these right now?
No.
Why not? They don't have the same insides. They have the same index, but the inside has to be the same. So I'm going to split it into my two problems and I'm going to break it down. So you should have used your trees and broke down, okay? And when I used my tree and break down, I should have gotten 3 times 3 times 3 times 2. What am I looking for? Groups of 3s. Why groups of 3s? My index is 3 right there. It tells me that's how many I need in a group. So I have 3 3s. I can take it out. So what's 3 times -2? -6. And then what's left inside? A 2. Okay. Let's go break down the other one. Oh, I see a negative inside. Can there be a negative inside?
No.
2 choices. What are they? I or -1. How do you know which one we're going to use? The odd index tells me I'm doing what? Making it a -1. Very good. So right now I have -4 cube roots. A -1 is outside. And when I break 16 down, I will have 2 times 2 times 2 times 2. What am I looking for? Groups of 3. So I can take a group of 2s out. And now let's multiply. What's 2 times -1 times -4? Positive 8 cube roots of 2. Now, what can I do? Am I subtracting? Now I'm adding because my signs changed, right? My signs changed. So I can only add the outsides. What's -6 and +8? +2. Does anything else change? No. So there would be my final answer. Okay. Questions on number 1? No. All right, here we go. Let's go convert. It doesn't say simplify. It just says convert. That means I'm changing it from an exponent to a radical or a radical to an exponent. What's the very first thing you notice in the top one? It has a negative sign. Okay. That negative sign, remember, means that somewhere I'm going to have a big fraction. So let's pretend the negative sign's not there. So if I pretend this negative sign's not there, how would I write it? I'd have a radical. What goes inside? X. I need a power and an index. What's my power? 1. Do I ever write power of 1? What's my index? And where does that go? In that little bitty check mark outside. This is a positive exponent. What does my negative exponent tell me to do? Anybody remember? To put it under 1. So remember, this is my fraction right now. And since it's negative, this whole thing has to flip. So it's really going to say 1 over the 4th root of x. That would be my answer because of the negative exponent. I promise you're going to have to know that. Okay? So the negative exponent tells me I'm going to have a big fraction for my answer. The second one is already a radical. I got to give it a teeny tiny exponent. What is my base of my answer going to be? And how do you tell somebody it has to stay together? Parentheses. I need a power and an index. What's my power? And what's my index? Why is my index 2? There's nothing there. How am I going to write my fraction? 5 over 2 or 2 over 5? 5 over 2. Y'all, it's got to be teeny tiny. Okay. Now, really quick, is this the same answer?
No.
Why not?
Because the x is the only one touching.
Only the x is touching that exponent. It's got to be the whole thing. Okay. Last what if. Is this the same thing? No. That exponent has to be an exponent. This will be counted wrong. Okay. So you have to have a teeny tiny exponent, not a big number next to it. Okay, questions? So today we're going to combine everything we have learned, all of it, into one new thing. And that's going to be multiplication. So at the top of your paper, at the top of our paper, we're going to have Unit 9. Topic 3, this is the last thing we're learning before spring break. This is still operations of radicals. Just a second, I'll focus it. Operations of radicals. When is your quiz? Thursday. Well, then you've taken it Wednesday. At the top of your paper, really big, just like we wrote add and subtract, I would write multiply or multiplication, whichever one you want. That way, you know these are your notes for multiply. Now, multiplication can be a lot easier than adding and subtracting because I can multiply anything in the world, okay? However, it gets messy. So I'm going to teach you a way to keep it nice, neat, and organized. And some of you crazies going to be like, no, I know better than Miss Bailey, and I'm going to do it my way. And you're going to fail because it's not going to be organized. It has to stay nice and neat or it's going to be everywhere, okay? So I really need you to follow the same thing I do. All right, so there are 3 rules. Rule number 1, the index must match. Rule number 2, outside times outside. I can't mix outside and inside. They're on different sides of a house. Can't go into the other side of somebody's house, okay? Number 3 is inside times inside. Those are my 3 rules. Index has to match, outside times outside, inside times inside. Here's my biggest piece of advice. Multiply first, break down second. So it's kind of like opposite of adding and subtracting. When we multiply, we want to multiply first, then break down, okay? We're going to do 3 examples and see if we are comfortable enough moving on or if we need to freeze and practice those 3 types of problems, okay? All right, so example number 1 is going to say square root of 8 times square root of 6. So the only thing I really have to check is, do they have the same index? So do these have the same index? Yes. Now we can multiply outside with outside. Do either one of these have an outside number? They do, but it's not written. What is it? A 1, but 1s don't really matter, okay? Inside with inside. So what is 8 times 6? So I have the square root of 48. And now I can break it down. Since I multiplied first, break down second. So what can 48 break down into? Right there. What did we multiply to get 48? 8 and 6. Do I have to use those? No, but when you get some wonky numbers like 236 and you're like, what goes into that? Well, use the numbers you multiplied. Okay. So I have 8 and 6. 8 can break down 4 and 2. 2 and 2. I'm going quickly through this because we've been practicing this part a lot. 3 and 2. All right, so when I write my nice long square root, I have 4 2s and a 3. What am I looking for? Groups of 2. So I can take out a 2, take out a 2. What do I do to numbers outside? Multiply. So 2 times 2 is 4. And what's left inside? 3. So there is my answer. Now, if you have time, then you can check your answer. So get your calculators really quick. We're not going to check every single one of them. You can, but we're not going to in our notes, okay? But we'll check 1 or 2 of them. So here's what I can do. Type in the problem exactly as it says, square root of 8. And then I'm going to hit the over button so it gets out of the radical, times the square root of 6. And when I hit enter, I get a really ugly decimal, but that's okay. Now, type in what we got as an answer. 4 square roots of 3. And when I hit enter, what do I hope is there? The same decimal. Is the same decimal there? So what's that probably tell you about your answer? It's correct, or you're really lucky, one of the two, okay? All right, let's go to example number 2. So example number 2 is going to say 2 square roots of 6, parentheses, 3 square roots of 3 plus square root of 2. Okay, now here's where I'm telling you you're going to have to keep it nice and neat. Everything needs an inside, everything needs an outside. So let's start there. Do we have an outside and an inside? Yes. Do we have an outside and an inside? Do we have an outside? We do. What is it? Then write it so your brain sees it. Okay. All right. So here's where I need the organization. Okay. So I have 1 number outside, 2 numbers inside. I'm going to make a box that shows that. So I'm going to have 1 by 2. So I'm going to make my boxes 1 by 2. Does everybody see what I did there? Okay. 1 outside, 2 insides. So I'm going to have 2 square roots of 6. That's on the outside. And then my 2 numbers have to go on the top. So 3 square roots of 3 plus 1 square root of 2. Does everybody understand how we organized that? Okay. You can't switch them. You can't move them in different places. So the first one stays outside. The inside stays together on the top. Okay. Now we're going to multiply outside with outside, inside with inside. So let's just look at the first one. What numbers are outside? 2 times 3. What's 2 times 3? 6. Now let's multiply what's inside. What's inside? 6 times 3, which gives me 18. Now we got to go to the next one. So I'm multiplying 2 square roots of 6 times 1 square root of 2. So what's outside? 2 times 1, which would give me +2. I'm going to write my symbol so I know in a minute what I'm writing. And then what is 6 times 2 is 12. So when I write this, I'm going to take everything out of the box and write it in one straight line. So I have 6 square roots of 18 plus 2 square roots of 12. Well, now that looks kind of like our warm-up problem. It's an addition problem. What do I know has to be the same for an addition problem? The inside. So we're going to break it down like we did before. So take 1 minute and break your 18 and take your 12 and then look up to see if we get the same thing. Don't just copy, really try to break it down. Remember, if you don't know, go to the side and make your trees. That's what you should be doing, or making them right there if you can keep it nice and neat. When you're done, look up just to see if we broke it down correctly or broke it down the same. Don't just copy. That's not going to let you learn it. What am I looking for? Groups of 2. Okay, so once you break it down, you got to take your groups down. All right, so I have 18 square roots of 2 plus 4 square roots of 3. Can I actually add those together? Why not? The insides don't match. So what will my answer be? Exactly that. I'm just going to rewrite it below because I have that line in the middle. 8 square roots of 2 plus 4 square roots of 3. Very good. Okay. We're going to try one more like this. Okay. Here's the last one, and then we'll decide if we want to practice or keep going. So I have the square root of 5m parentheses 6m squared minus 2 square roots of 5. So let's make sure everything has an inside and an outside. So my first term, what's missing, the inside or the outside? And what can I put there? A 1. Then look inside, my first term, 6m squared. What is it missing? The square root. I can still add a square root of 1. Anytime I need to, I can add a 1. And then does my last one, it has an outside and an inside. So let's draw our box. How many are outside? 1, and inside. So I need a 1 by 2. Okay, so I'm going to have a 1 by 2, just like we had last time. So outside will be my 1 square root of 5m. And then on top is what's in my parentheses. 6m squared, square root 1. I'm just rewriting it. Don't forget to keep your sign. -2 square root 5. Okay. So let's multiply. In the first one, what's the first thing I can multiply? 1 times 6m squared. What's 1 times 6m squared? 6m squared. And I have to multiply the inside. What's 5m times 1? 5m stays inside. Okay. Now let's go to the next box. I have 1 times -2. So what's outside? -2. And what's going to be inside? 25m. 5 times 5 is 25 and m. So now let's take it out of our box and write it to the side. So I have 6m squared, square root of 5m, minus 2 square roots of 25m. Can I actually subtract those? No, the insides don't match, but can we break them down? Yes, so go break down your problem for me. Look up to check if we have the same answer. Does the first one break down at all? No, so you're just going to bring that straight down. Just drag that answer straight down. And then you got to break down your 25. 25 breaks down into 5 times 5. And what am I looking for? Groups of 2. So I can take the 5 out. So now this is what I have left over. Can I add those together? Why not? They both have an M. The inside is not exactly the same. Are they exactly the same? They gotta be like identical twins, exactly the same. So can I actually add these together? So what's my answer? That is my answer. 6m squared, square root of 5m, minus 10 square root of m. Very good. Questions? Okay, I think it's a good idea to freeze here and get some practice in. What do y'all think? Yes? Okay. So in your packet that's at your desk, you will be on this page that says multiplication. It also still says do not write on this. However, today I taught you how to do numbers 1 through 20. That's what you've been taught how to do today, 1 through 20. So that's what I need you to work on today. And then tomorrow we will work on the ones that have a lot more terms in it. Okay? Are there questions? Make sure you get up and check your answers. They are on the front desk and I'll walk around and answer questions.